In this video, we're going to look at applying multiple graph transformations and consider the order in which we carry them out. Let's start off with some basics and look at the three different types of transformations. Let's start off with translations. If we have translations, we simply move the graph. So we're translating a curve, for example. If we have the f of x minus a, this will give us now a vector of a comma 0. So we move this a unit in the positive x direction, or to the right. If we have now the f of x plus a, we have a vector of 0a, and we move this a unit in the positive y direction, or if you like, parallel to the y-axis. So for example, if we have the f of x minus 2, this simply now moves 2 units to the right in the positive x direction. If we have f of x plus 1, we're going to move left by 1 unit in the x direction. The f of x plus 5, this will now move up by 5 units, and the f of x minus 3 would move down by 3 units. These are examples of translations. The way I like to think about this now is if it's on the inside, it will affect the x coordinates. If it's on the outside, it'll affect the y coordinates. Let's now look at reflections. So just writing this down, we have two different types of reflections. We have f of minus x. This now is a reflection in the y-axis, or if you like, the line x equals 0. So we can say now reflect in y-axis, or we can say the line x is equal to 0. If we have minus f of x, this now is a reflection, so we're going to reflect this in the x-axis. So we can say that this now is the line y is equal to 0. Again, if it's on the outside, it's going to affect the y coordinates. If it's on the inside, it will affect the x coordinates. So if we have a look at this now, what I'll do is a quick sketch up. Let's say now we have y is equal to the f of x, and the f of x is x squared. So here we have x squared. So y is equal to x squared. We've got this point here, 1, 1. We've got this point here, which is 2, 4. If we did now y is equal to minus x squared, which is the minus f of x, we would end up now with a reflection in the x-axis. This point would go to 1, but we'd have minus 1. This point would go to 2, and then we'd have minus 4. So all we're doing is simply reflecting in the x-axis of the line y equals 0. So all of the y coordinates change now their sign. Let's go ahead and look at the final one, stretches. Stretches seem to cause the most problems. If we start off now with the f of ax, this is a 1 over a scale factor stretch in the x direction. So we could say in the x direction or parallel to the x-axis. Depending on which exam board you do, some say in the x direction, some say parallel to the x-axis. If we have a f of x, we have now an a scale factor, so scale factor of a, and that's now in the y direction, or if you like, parallel to the y-axis. So again, if we just look at that now, let's say we've got our standard parabola, y is equal to x squared, and we look at a couple of examples. So now if we put the graph on, this is y is equal to x squared. If I take this point here, we know that is 1, 1. We've got this point just here, 2, 4. If I do 2f of x, this is on the outside. It's a scale factor stretch of 2 in the y direction. So what we end up with then is a graph that looks something like this. Or we could say y is equal to 2x squared. So this point, instead of becoming 1, 1, would go to this point right here, and that would be 1, 2. It's not brilliant, but it gives you some idea. 2, 4 would go to 2, 8, as we're simply multiplying, and it should be now parallel to the y-axis. If we had now f of 3x, we would divide now the x coordinates by 3. So this would become 1/3, 1. This would be 2/3, 1. It's simply saying now we need 1/3 of this number to achieve 1. If we had now f of 1/4 x, this is a scale factor stretch of 1/1/4, which is the same as 4, and our graph would look a lot flatter like so. So what we'd end up having is a point over here, and this would be 4, 1. So these are simple single transformations. What we're now going to do is look at applying more than one transformation and considering now if we need to factor in the order in which we carry these out. Let's start off with a basic rule. If our transformations are in different directions, it doesn't matter in which order we carry them out. So let's look at an example now. The f of x minus 1 plus 4. We've got one transformation in the x direction and we've got one in the y direction. These are two basic translations. We'll move right 1 and up 4. I could have moved now up 4 and right 1. The order doesn't matter. We have one in the x direction and we have one in the y direction. So the order doesn't matter. If we had 2 f of x plus 3, for example, so got 2. In fact, we'll do a different one. No, that one will be perfectly fine. Let's go for this one to begin with. What we have here is a scale factor stretch of 2, and this is going to be in the y direction, or parallel to the y-axis, and we have now a vector of minus 3, and this is translating now the curve 3 units to the left. This is in the y direction, this is in the x direction, and it doesn't matter again which order I carry them out. I could move it 3 to the left to begin with and then multiply by 2, or I could multiply the y coordinates by 2 and then move it to the left by 3. The order doesn't matter, as now one is in the x direction, one is in the y. Let's look at another one. Let's say we had the f of 3x minus 4. Again, we've got now two different directions. This now is a scale factor, so we can say SF of 1/3 in the x direction, or you could say parallel to the x-axis, and this is a simple translation, and we'd have the translation in the y direction of -4, or we would move it down. So that now does not matter which order we carry them out. Later on we will look at when we have multiple transformations in the same direction and then one in the other direction. Okay, let's now look at an example where we have 2 in the y direction. So we've got two different graph transformations and they're both in the y direction. What I'm looking to do is build up some rules that we can use and apply, and hopefully some examples will show you just how you can do this. So what we're going to have then is both in the y direction. So two transformations in the y direction. Let's just define a function. Let's say the f of x is equal to x squared plus 1. We've seen this graph before. It's a standard parabola. We're going to have now the point just here. We're going to have a minimum point at 0, 1. So let's have a look at it like so. So here's our parabola. Y is equal to x squared. It's symmetric about the y-axis. And we can say now y is equal to x squared plus 1. So we have this minimum point here, 0, 1, and we have no points of intersection with the x-axis. Let's now look at applying two different transformations, both in the y direction. I'm going to pick, let's say, 2 f of x minus 5. Now, which order do we carry these out in? We've got a scale factor stretch, so SF of 2 in the positive y direction, and we have a translation of minus 5. Again, this is in the y direction. So which do we do first? And let's now have a look at it. Now, we're doing two lots of the f of x minus 5. Now, if I just sub this in, what we're going to have, and you can do it, you can do it purely graphically. Let's do it by subbing this in. So what we're going to have then is two lots of x squared plus 1 and then we're going to have minus 5. So that's going to give me 2x squared plus 2 minus the 5, which is minus 3. Now if I went ahead and drew this graph, we're going to have a minimum point just here. The graph will look something like so, and when x is equal to 0, we will have now this point down here, which is 0, minus 3. Now the question is, was it the stretch followed by the translation, or was it the translation followed by the stretch? And this is the question that we're going to answer. Now let's consider this point here. Now with this point, we either multiplied the y coordinate by 2, which would have taken me up to 2, and then subtracted 5, or what we did is first subtracted the 5, which would have taken me down to minus 4, and then multiplied now by 2, which would have taken me down to the minus 8 just here. So we can quite clearly see that the first thing that we did here was applied the stretch. So when we have both in the y direction, we do the stretch, so writing this out, the stretch followed by, and just jotting this down, followed by, and making this clear, or you could state then we carry out the translation. So we go now with the stretch first, then the translation. By considering a point, we can see that's clearly the case. So for example, now if we had, let's say, we'll do 1/3, and then we've got the f of x plus 1. We would carry out now the stretch first, then the translation. So we'd have a 1/3 scale factor stretch in the y direction, or parallel to the y-axis, just jotting this down. Then, or followed by, I like to write then, we would apply now the translation, and the translation now would be 0, 1, or we could say 1 unit in the the positive y direction. So positive y direction, or parallel to the y-axis. So this is your take-home point. If you're in doubt, pick a graph you know and consider what happens if you apply it. Now we can quickly draw this graph. I've shown 2 lots of the f of x. This is the f of x. Minus 5 gives us this. We can graph this and consider this point. So just to highlight this, when both are in the y, so both now transformations are in the same direction and they're both in y, we do the stretch first, then the translation. Okay, let's go ahead now and look at when we have both of these in the x direction. So we're going to have 2 transformations, and let's say now both in x direction. So what I'm going to do is just define a function. Let's just take a function. Let's say f of x. Let's go for f of x is equal to, and we'll pick a parabola. So let's go for x squared minus x minus 6. If we went ahead and factor this, let's go ahead and factor. We've got x minus 3 multiplied by x plus 2. So nice straightforward parabola. Let's go ahead and do that, and we can just draw our sketch up here. Okay, let's do that. So we're going to have a point here. This is going to be minus 2, and this is going to be 3. So the solutions when this would be equal to 0 would give us now minus 2 and 3. So here's my parabola. We're symmetric about the line just here, and we're going to have this line just here, and we're going to have minus 2, 0, and then we're going to have 3, 0. Now let's look at applying a transformation, and I'm going to do the f, and let's just do 2x minus 1. So what we have now is a stretch. So this first one is a stretch, and we have now a scale factor of now 1 over 2. So it's 1 over 2 in the x direction, or parallel to the x-axis. And this one now is a translation of 1 unit to the right. So we've got 2 to deal with. And the question is, which do we do first? So let's think about what's going to happen to these points. What I'm now going to do is the f of 2x minus 1. Now if I sub these in, and I'll do it step by step, we're going to have 2x minus 1 minus 3. Then we're going to have 2x minus 1 plus 2. So let's consider what's happening. Now this point right here, let's just do this. That one is going to go over here. this one is going to go over here. Now this one here is going to correspond to the coordinate of what happens to the 3, and this one will correspond now to what happens to the -2. So if we just tidy this up here, f of 2x minus 1 is going to give us 2x minus 4, and then we're going to have now on here 2x plus 1. So let's consider solutions now to this particular equation and consider what's happened. Now that one is going to go to 2, okay? If we solve this, I mean, we can take the factor of 2 out if you wanted, and that is going to go to 2. So it went from 3 to 2. This one here is going from -2, and it's going to go to -1/2. So that one, after the 2x minus 1, will change to -1/2 if we set these equal to 0. Now let's have a think. Here's the question. Did we do the stretch followed by the translation, or did we do the translation followed by the stretch? Now this might be intuitive and you might be already comfortable given what we've looked at in the y direction. So let's pick this point here. Now our choices are, we've added 1, which is the translation, and then divided by 2. So if I added 1, that would take me to the 4, and then divided by 2, that would take me back to the 2. Now, does that work? Well, let's have a look at this one. If I now moved this one from -2 and I translated it now 1 unit to the right, that would give me -1, and then I half it, and that gives me -1/2. So we can see this time we've done the translation first, so it's the translation, and then we've done it followed by, or if you like, then, I like then, the stretch. So this time it's the opposite, and as stated, that might be intuitive for you. But if we take this one now, we did the stretch, then the translation in the y direction, and this one, we did the translation, then the stretch. Again, you might have built up the function from scratch, and it's perfectly fine to consider it that way. But if you want some hard and fast rules, generally this is what you're going to employ. And it's fantastic as well if you want to try it with some trig functions and graph them and solve equations. It really is quite interesting. So what we've got then is a translation followed by the stretch. Okay, now that is the case. So what we've got here is where we've got them both in either the x direction or both in the y direction. So the question is now, is if we have now, let's think of another set of transformations. Let's say we have 2f of, let's say, 3x minus 1. So this time we've got 3 different transformations going on. That is a scale factor 2 stretch in the y direction. So we got that one, that's there. Now this is the 1 over 3 in the x, so 1 over 3 scale factor stretch, or if you like, parallel to the x-axis. And then this is a translation again, so we've got a translation, and that is in the x direction. If you like, if the vector is 1, 0, or you could say 1 unit in positive x direction. It all depends on the terminology that you're used to. Now with this one, it doesn't matter if we carry the y out first or the x's. If we carry out the x's, we have to keep the order. So what you might want to do, and again, it might be intuitive and you might not want to think about it like this, what I could do now is the following. I'm just going to draw these boxes. So what you might have is something that looks like this. So I'm going to have now, let's do that. So let's go there. So this one is y, then I'm going to deal with the x's. This one is the x's, then I'm going to deal with the y's. So what we could do now is carry out the y first, and we could do our SF2, so putting this information in the y direction stretch. Then what we would do is our translation, so it'd be our translation, so we'd have our translation of 1, 0, followed by, or then, now our stretch of 1/3 parallel to x, so parallel to x-axis. Alternatively, what we could have done is that one first, and then that one. As long as we're doing these two in this order, it doesn't matter if we do the y's first or the x's. And it just gives you some idea. So we're kind of using the same rules. But again, we're going back. If they're in the two different directions, you can choose which you do first. If they're in the same direction, you need to consider the order. There are some variations on that. Let's think of another one. Let's do the f, and let's go for the f of 2x plus 5, and then we do minus 2. Now, what we've got here are, again, 3 different transformations. That is in the y direction, and that's a vector of 0, minus 2. So this is now translating. So we're translating now negative 2 in the y direction. That's a scale factor stretch, so SF 1/2 parallel to x. And this is a translation now. So that gives me a translation of minus 5, 0. Okay, we could go ahead and carry out the x's in the order, which is the translation, then the stretch, and then apply the translation in the y direction. Alternatively, you could just consider carrying out the 2 translations and then the stretch in the x direction. I think keeping it consistent, just say, well, I'm going to deal with the x's and then I'm going to deal with the y's, so I'm going to deal with the y's and the x's. But this translation, as long as we're carrying out the translation in the x before the stretch, we can actually do the translation together. I would prefer to think about it like this if you kind of want it in a very algorithmic term. But essentially, with our translation, we could carry this out as a combined translation and then apply the stretch. Hopefully that hasn't baffled you too much, but it should give you some idea of the order in which you could carry them out. There's also the idea, if you wanted to look at one now, as the f, and then if we had the f of minus x plus 2, you can consider this one. Again, you might want to look at this as a reflection, or you might want to look at it as a scale factor stretch now of minus 1. Either way round, we would carry out now the translation and then we would do the reflection or the stretch. So there we go. Hopefully that's been of some use. It doesn't appear on all exam boards, and the terminology used is different from exam board to exam board, but hopefully it gives you some idea on these successive or multiple graph transformations and the order in which you carry them out.